Okay, we're gonna do question 8 here. If you have 4 number 10 and 4 number 14 and 4 number 12 AWG R90 XLPE solid copper 600 volt non-jacketed conductors installed in the same conduit, what is the minimum size EMT conduit you can use according to the code? So we got to go through a bit of a process here to figure out what size EMT we're gonna need. And that's because we're dealing with 3 different size conductors. If you were dealing with all the same size conductor, then you could bypass a lot of these steps and simply go to table 6. Find the appropriate subtable within table 6 and figure out your answer very quickly. But in our case, we're dealing with 3 different types. So we got to go through 3 different tables. First being table 10. And because we're dealing with solid copper, we're going to go to table 10C, which deals with solid. And you'll see here in table 10C that there's only actually 3 different available conductor sizes. And that's because after anything larger than number 10 AWG conductor is going to be stranded. So we're dealing with R90 XLPE 600 volt insulation rating. So that's going to be a little bit smaller in diameter and have a little less area than 1000 volts, as we can see here. So we're going to stick with this first column. So we're dealing with 4 number 14s, and one number 14 AWG conductor has this area of 7.78. 12 has 10.02, and number 10 has 13.25. But we have 4 of each, so we got to multiply each of these areas by 4. So by doing that, we're figuring out the total area that's going to be taken up by these 12 conductors. So number 10 was 13.25 millimeters squared. So we're going to multiply that by 4. The number 12s were 10.02 millimeters squared times 4 because there's 4 of them. And the number 14s were 7.78 millimeters squared multiplied by 4 because there were 4 of them. So that's going to give us 53, a total of 53 millimeters squared for the number 10s, a total of 40.08 millimeters squared for the number 12s, and a total of 31.12 millimeters squared for the number 14s. If we add all these up, that's going to give us our total area taken up by the conductor, which is 124.2 millimeters squared. So first step, table 10. Second step is table 8. What table 8 tells us is how much we can actually fill that conduit up to. So you would never want to fill a conduit to 100% of its capacity. Otherwise, it's going to be, when you think about pulling that many conductors through a conduit, it's going to be impossible to pull all those in. So table 8 is a maximum allowable percent conduit and tubing fill. So how much can you fill that conduit to? And you're going to be dealing with this here. Conductors are multi-conductor cables, not lead sheath. So lead sheath cable or conductors aren't very common anymore. So primarily it's going to be this row that we deal with. And we're dealing with over 4 of them. We got 12 total. So you can fill up that conduit to 40% of its capacity. 40%. But we don't have to do any math here. We just need to know that you can fill it up to 40%. Our next step, so that's table 8, 40%. We can fill up that conduit too. Now we go to table 9, and we got to find our subtable that is going to deal with our particular conduit. So in our case, we're dealing with EMT. So let's go to table 9 here, and you'll see that the first one here is for rigid metal conduit, so that's not going to help us. Second one for flexible metal conduit. EMT you're going to find in subtable I here. So cross-sectional areas of electrical and metallic tubing, or EMT. Now, all we got to do is go to the 40% column here, because we already know that we determined in table 8 that we can fill it up to 40%. Now we're going to look for the total area taken up by the conductors that we found out in step 1, looking at table 10C. And we determined that it's going to take up a total area of 124.2 millimeters squared. So that's going to leave us here. We can't use nominal conduit size 16 or trade size 16 because that's only good for 75 square millimeters, but we can use trade size 21, as that is good for 132 millimeters squared, which is more than what we need. So the answer to our question then is the minimum size EMT conduit we can use is trade diameter 21. So that's how you do a question for figuring out your conduit size for situations where you have different size conductors running through that single conduit.